Right, so in this module, we're going to talk about a sort of a little bit of an obscure feature of variables and local variables within functions called global variables. And in Python, global variables are directly supported in the language through some special syntax, um, which is not found in other languages that make global variables a little bit more usable than they would be in other languages. But nevertheless, this is a feature that should be used with caution and generally um, should only be used when you absolutely need to. And we're going to I'm going to explain um, why that is and some situations where you might find it useful. So to understand global variables, we need to go back to the idea of variable scope. So Python has a um, very clear, well-defined mechanism for deciding whether or not a variable is local to a particular function. If a variable is assigned, if it's changed, if it's on the left-hand side of an assignment operator, it is no matter what a local variable to the function in which it's being assigned in. Okay, and so whenever you see x equals 5 in a function, you know that that x is a local variable within that function. Even if there's an x outside of the function at the parent scope, it's not being used. If a variable is referenced, then it might not be a local variable. If it is not assigned, it's not a local variable, and as long as it has been bound to a parent scope, it would be able to be used. So 99.99% of the time, this is exactly the way we would prefer the programs to work. This makes the most sense. It actually is a very reasonable way of scoping or limiting the scope of variables. And it's considered an excellent feature of the Python language. Every once in a while, though, we would benefit from the ability to assign or change a variable inside of a function that is defined outside of that function. All right, so every once in a while, we're going to want to be able to assign a variable which is outside of our own function's scope. All right, and a real classic example of this is trying to determine maybe how many times a given function has been called. So I want to, one of the programming examples from the recursive module was calculation of the Fibonacci sequence. And we did the Fibonacci sequence recursively, and we also did it iteratively. And we saw that um, the recursive implementation actually took really, really long for larger numbers, for larger values of the sequence. And it had to do, kind of implicitly, we knew it sort of had to do with a lot of function calls, but we know the runtime just exploded. Somewhere around 30 started to really increase dramatically. It's actually, since I only plotted a couple data points, it looks like sort of a linear curve, but really this is an exponential curve. I'm only approximating because I only have a few data points. So we know that the runtime explodes. We have a feeling it's because the number of calls to Fibonacci is really, really high. It would be nice to be able to actually implement that. So if I go to the code, um, I have this is the solution for programming example 14. I just carried this over. Um, excuse me. We could get a variable. We could just say um, num calls, right? And we can do plus equals 1, right? Now, just the idea behind this is that, okay, well, we have a variable that represents how many times we've called Fibonacci. Now, that hopefully you recognize that is not going to work. So if we try to run this thing, actually, we immediately get, well, I'm going to lose that colon, actually. Okay, and let's rerun that. Okay, so if we run this, we're going to immediately get an error, and it says numcalls reference before assignment. All right, and so this sort of makes some sense because the first time we call Fibonacci, numCalls doesn't have a value. And so plus equals 1 really is the same as writing numCalls plus 1. And of course, this doesn't make any sense because the numCalls doesn't have a value yet. All right, so we can't use it on the right-hand side. Now, it would stand to reason that maybe we could do, before we call it, we could say numCalls equals 0. And somehow that would work. And in fact, if we run this, let's see what ends up happening. And we still are having the numCalls. Whoops, I don't think I say, or the numCalls being referenced before it was assigned. The plus equals 1. Right? And so why is that? Why didn't this help? All right. Well, it didn't help because this is an assignment statement, right? Again, we can rewrite this as numCalls plus 1, and because it's an assignment statement, numCalls is implicitly a local variable. Right? It must be a local variable to fib, no matter what. No, this doesn't make any difference, the fact that fib is down here. So the way we handle this in Python is actually to declare inside the scope that we're using the variable that the specific variable is global. All right, and what global means is that the variable is defined at a sort of a parent of the parent. It's a global scope. It's defined above all of the scope of all the functions in the code in this program. When you type global numCalls, any kind of action taken on that variable is assumed to be on the global version of it. Now, an important aspect of this is that this has to be declared also inside the function that's going to be used. Right? So anytime that I'm going to assign numCalls, I need to include the reference global numCalls. Right? That's telling us that yes, this might be an assignment, but this is not an assignment of a local variable. This is an assignment of the globally scoped variable. So if I run this now, everything goes well. I have to actually print out the number of function calls that I made. So let's go do that. Print fib was called calls. And the way this program is designed to work is that numCalls gets initialized to 0, and then we call fib. And every single time we call fib, we are declaring that any reference to numCalls corresponds to the global one, and we're going to increment it by 1. That variable scope survives leaving the fib function. It's in the permanent global scope. So if I run this again, we see that Fibonacci was called 9 individual times. If we type in 30, we start to get a picture of just how many times Fibonacci is actually being called. Right? We're looking at something in the order of over 2 million Fibonacci calls. All right, and so that's giving us a much more accurate description as to why that recursive call is so slow. And it's a nice usage of global variables. Note, there really is no other way to make this happen, to make this work. We don't have a loop that's calling fib over and over again, so there'd be no way to sort of have an outside counter. The only way to make this happen is to have a counter inside the actual function call, and the only way to make that work is using this global keyword. Okay, so I want to compare and contrast global variables in Python and in other languages. So if this is the first language you ever learned, this is all you know about global variables, okay, that's great. And what you should know is that global variables allow you to sort of break the syntax, the scoping rules of the language, and it allows you to overwrite or assign variables that are currently outside of your scope. If you're familiar with other languages, you probably already know that global variables are sort of frowned upon. And they're frowned upon in Python as well. They should not be used when they don't need to be. However, The nature of global variables in Python is indeed very, very different than most other languages. And this has a lot to do with the fact that assignment, not reference, defines scope in Python. So unlike other languages, Python requires the programmer to be explicit about using global variables. If you think back to what you might know about global variables in other languages, it's sort of implied. You have a global variable defined outside of, of functions. Anytime you use a variable of that name, it's automatically going to maintain that scope or maintain that reference to the global variable. The fact that in Python we have to explicitly in every single function that we use the global variable actually type global and then the variable name is actually a really big, it's a positive. It makes it much more clear and a much more conscious effort to use global variables if you're trying to do that. The biggest problem with global variables tends to be using them accidentally, having naming conflicts. So the way Python works kind of eliminates some of that. So that's a good thing. Um, in general, no matter what, global variables should be used with extreme caution. The scoping rules of variables within functions is actually, it's hard to understand in the beginning, but it is there to help. The way the scoping operators, the scoping rules work for variables in Python really helps eliminate many, many programming errors to the degree where you don't really even encounter them anymore. The moment you start to use global variables, you're opening yourself sort of wide open to some very, very nasty bugs. They also lead to some hard to read code and very hard to debug code. So again, global variables allow us to use a variable and assign a variable within a function that is actually defined at an outer scope, at a global scope. So we can define or assign the value of a function, a value of a variable via many different functions if we need to. However, this does not replace return values. It does not replace parameter passing. You should never use global variables to get around passing things into functions or anything like that. They should always be used with care.